Okay, so now that we understand what we mean by permutation, or basically the permutations, all the basically total number of permutations of the letters of the word, for example, independence, what we mean by that. So let's calculate it. So to calculate the permutations of the letters of the word independence, of course you do need to gather some information, meaning that you need to know how many letters or how many objects you have in total, and then if your objects are unique or not, or are distinct or not. If your objects are distinct, then you don't, of course you don't have these, for example, n repeats and basically appears 3 times, d appears 2 times, e appears 4 times, and so on and so forth. Otherwise, if they are unique, well, of course you don't have these. But since the objects that I have here are not distinct, then I have to add this information as well. And so we said that basically the number of permutations of these letters is equal to, of course, you know that you can calculate the permutation using the formula that we derived, which is n permutation r is equal to n factorial over n minus r factorial, which is over here basically your n is equal to 12 because you have 12 objects, and your r is equal to 12 because you are, out of these 12 objects, you're creating basically for example, if you have 12 letters, and out of those 12 letters you are creating 12 letter words, then your r becomes 12. If out of those 12 letters you're creating 10 letter words, then your r becomes 10, meaning that n permutation r, or for example 12 permutation 10, you can think of that as basically 12 objects basically taken, for example, taken 10 at a time. That's the meaning of the 12, for example, permutation 10. So then, of course, I can calculate the permutation of, for example, 12 permutation 12, which is equal to 12 factorial, because you have 12 factorial here and 12 minus 12 factorial, which is equal to this is 0 factorial, which is equal to 1, so this is 12 factorial. Now you have 12 factorial, and based on the problem that we solved about the example of where basically the example where we had basically 2 O's repeating in the word, which was, I don't remember what that was, but there was something like T-O-O-R or something like that. Over here we had two O's basically occurring twice. So we calculated the permutation of these 2 O's, which is basically 2 objects taken 2 at a time, or taken all at a time, which would be basically 2 permutation 2, which is again 2 factorial. Actually, factorial has to be written this way. So 2 factorial. And then we got all the permutations related to this word, which was 4 factorial, and divided that by 2 factorial to get the distinct number of permutations of the word. So we have to do the same thing over here, meaning that we take our 12 factorial and divide it by the permutations, by the individual permutations of these words, meaning that you have basically, so then based on this you can say that the total number of number of distinct permutations is equal to, and of course you don't have to say distinct, because permutation by nature and by definition is supposed to be distinct, so you don't have to say it, but I've written it so that you know that I'm explicitly calculating the number of, well, distinct permutations. And so I have to take my 12 factorial and divide it by basically the permutations related to the word n, related to the letter n, which is 3. It basically occurs 3 times, so that the permutations related to this letter would be 3 factorial. D occurs 2 times, so the permutations related to that is 2 factorial. E occurs 4 times, so the permutations related to that would be 4 factorial. And so that is equal to basically 4 factorial times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 divided by 3 times 2 times 2 over here, and 2 times 3 times 4 factorial. And well, 3 factorial, and well, I should have left, well, I can write 4 factorial as 2 times 3 times 4, 2 times 3 times 4, and so 2 times 3 I can cancel out with these, and 4 I can cancel out with this, and 2 times 2 I can cancel out with, for example, 2 times 2 is equal to 4, 12 divided by 4 is equal to 3, 3 and 3 I can cancel out, everything is cancelled out here. So I have 30 times, this is 30 times 56, 30 times 56 times 99 times 10, which is equal to 990. So I can multiply, for example, 99 times 3, and then I have 2 zeros there. So that's 27, 29, and then I have 2 zeros there, so that's my number. And I have to multiply it by 56. So I write 297 and 2 zeros times 56, which is equal to 42, 4, 54, 58, 5, 12 and 17. 12 plus 5 is equal to 17, 0, 5 times 7 is equal to 35, 3, 5 times 45, 48, 4, and 5 times 2 is 10, 14. You have a 2, you have a 13, 1, 16, 1, 6, 1, and you have 2 zeros there. That's the same thing as 1, 6, 6, 3, 2, 0, 0. So the different, basically the permutations related to the word independence is basically 1,663,200, which is exactly the right answer. Now the part 1 of this question is in how many of these arrangements do the words start with a P? Words start with a P. So you want to calculate in how many of these arrangements do the words start with start with a P. So now to calculate this is simple. It's not really complicated in any way. Of course, you need to know how to do it. Otherwise, if you know how to do it, it's easy to calculate it. So the word independence, so if I want to calculate all of the permutations related to the word independence, in such a way that the words start with a P. So what I can do is that basically I know that here, so suppose that I'm making these, I'm creating these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 digit words. 12 digit, 12 letter words. I have 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. 12 letter words. So if I'm creating these 12 letter words, now what I can do is that since I want all the words to start with a P, what I will do is that I fix a P at this well, placeholder, I would call it, right? And of course, you know that I have 12 letters in total here. 12 letters in total here, and again, the same thing over here. N, D, and E are basically 3, 2, and 4 times. 3, 2, and 4 times. They appear 3 and 2 and 4 times. So what I need to do is that first I need to calculate all the permutations related to such words where the word starts with a P, right? And since the word starts with a P, there is only one way of filling this placeholder. And then since I have 12 letters in total, so since I have used one of them, so then there is 11 ways of filling this placeholder. After that, there is 10 ways of filling this placeholder. 9, 8, 7, 6, 5, 4, 3, 2, and 1. So that means that then all of these numbers, and so the total ways the total number of ways of filling all the placeholders. In other words, all the possible arrangements of the 12 letters, assuming that the first letter of the word is always a P, so then the total number of ways of filling the placeholders of all the placeholders, in other words, all the possible arrangements of the 12 letters, assuming that the first letter of the word is always a P, is basically, of course, by the fundamental principle of counting. By the fundamental principle of counting is basically 1 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as, so this part is the same thing as 11 factorial. This is equal to 11 factorial. So that is equal to actually 11 factorial, right? And of course there is something here that we need to take into consideration as well, that these also repeat themselves. Now basically, if I call this for example A, now basically recalculating A, taking the repeating letters into consideration, we have basically the new distinct number of permutations would be equal to 11 factorial. And then you have to take these out because they are repeating. So we have 3 factorial, 2 factorial, and 4 factorial. We have 3 factorial, 2 factorial, and 4 factorial. And so you get basically you get 4 factorial times 5 times 6, 5 times 6 times 7 times 8 times 9 times 10 times 11 divided by 4 factorial times, this is a 6 and a 2, so this is these two multiplied together, that would be a 12. And so these two you can cancel out. You get a 2 here, 2, you get a 4 here. So that's a 35, that's 36 and 110. 36 times 110. And that is equal to, so that's 35, 36, and 110. So you have 36 times 35, which is equal to 33, 15, 18, and 18, 1, 9, 10, 8, 8, 288. Now 288 times 11 with a 0. You get 288, 0, 288, 8, 16, 1, 11, and 3, and a 0, so you get 31680. That is the total number of distinct permutations of the word when all the words basically start with a P. So that is that. 31.6. I think I have forgotten something. A 0, I have kind of forgotten a 0 there. Let's see. 35 times 36 times 110 is 1386. 1386. This is wrong. This is supposed to be, I don't know what I did there, but this is supposed to be 13, 86, and 00. That is the right answer. That was the first part of this question. So basically, whenever, for example, you know that, for example, the word is supposed to start with whatever it is that the word or the number starts with, what you do is that you fix that digit or you fix that letter wherever it is in your number or in your word, and then based on that you can calculate the different permutations or whatever it is that you need to calculate in that particular case. So that was the first part of this question. So now let's see what the second part is. Okay, so the next part of this question is basically in how many of these permutations, which was basically these permutations here, around 1,663,200, in how many of those permutations do all the vowels always occur together? So all the vowels occurring together. So let's go somewhere and let me actually take a screenshot here. That's possible. Make it 50%, for example. Okay, so I make it screenshot here. Oh, there's something that doesn't. No, it seems that it doesn't work. Oh. No, it doesn't work. Okay, so if we need to, we'll have to come back to this page again. That's okay. That's no problem. Okay, so what we want to know in how many of those permutations do all the vowels always occur together. So we have the word, basically we have the word independence. And in how many of those permutations we mean that the one that is around 1,663,200 permutations which we calculated, do the vowels always occur together? So in order to calculate that, basically in the word independence you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 2, 4, 6, 8, 10, and 12 letters. You have 12 letters. There are words that repeat. There are letters that repeat themselves. For example, N repeats itself or occurs basically 1, 2, and 3 times. N occurs 3 times. D occurs 1, 2, 2 times. D occurs 2 times. and E occurs 3 times. Independence. So one of them is supposed to occur 4 times, if I'm not mistaken. Let me see. 1, 2, 3, and 4. So E 1, 2, 3, and 4. So E occurs 4 times. And then the rest of the letters do not repeat. I have I over here, I have P over here, they do not repeat. So this is the information related to the word and the number of objects, the number of letters, and so on and so forth. Now the vowels in this word, the vowels in this word are I, E, and I, E, and that's I and E. So you have I over here, E over here, E over here, E over here, and E. So you have 2 vowels in this word. So so now what we want to do, so in order to understand how many of these permutations the vowels always occur together, okay, so we do need to basically all the vowels that I have in this word are basically one I. I have one I here and I have 4 E's here, right? So to make things simpler, of course there might be some other way not to do this, meaning that what I want to do is that I want to make a group of all of these vowels, meaning that I want to make a group of I's and E and E and E and E. And so I have 4 E's here and 1 I here, and group them all together as one object, and then the rest of the letters here would be basically, this is 4 plus 1 is equal to 5, and 5 plus 7 is equal to 12. So you have another 7 letters here, meaning that you have plus another 7 letters, right? So you have 5 plus 7 is equal to 12 letters in total. So I group all of these vowels together so that, and then I treat this as just one, I treat this as one single object, and so now what would you do? Right now, as you can see, I have basically these 7 objects over here and 1 object over here, so I have 8 objects. So over here I have 8 objects. Now what would you do if you were to calculate the permutation of 8 different objects? To calculate the permutation of 8 different objects, you would write 8 permutation 8, which is equal to 8 factorial, right? Now, in these objects, basically, we said that the E's are basically, they repeat themselves, but since they are treated as just one single object for now, I'm not I'm not concerned about E repeating itself 4 times or so. So that's not a problem right now. But D and N repeat themselves, one of them 3 times, one of them 2 times, meaning that N occurs 3 times, D occurs 2 times. So that means that to calculate the number of, or basically the distinct number of permutations would be equal to 8 factorial, and then you have to take out basically those 2 letters that repeat themselves, except for E, because E has been treated right now. I'm treating it as just all of these basic letters put together. I'm treating them as just one single letter. So I have to take out basically the repetition of these 2 letters N and D. So I divide by 3 factorial and 2 factorial. 3 factorial and 2 factorial. So that's the distinct number of permutations of these letters. And also because these, now we treated these 5 letters as just one single object, but of course you know that basically when you have 5 different letters put together, there will be a certain number of permutations related to those 5 letters themselves. Because, for example, suppose that you had, for example, A, B, C, D, and E, and so you could rearrange these letters in many different ways. Actually, in 5 factorial different ways, you could rearrange these letters and take basically get different arrangements related to these letters. So I have to basically take that also into consideration, and calculate the permutation related to these letters as well. So what is how would you calculate the permutation of 5 different letters? So the permutation of 5 different letters I'm saying, but of course these are not different, and we will take care of that in just a moment. If I were to calculate the permutation of 5 different letters, that would be basically 5 factorial. Now, out of these 5 different letters, one of them repeats itself 4 times. So I have to divide this by 4 factorial, right? So what I can do is that now, since relative to each of these distinct permutations, there is 5 factorial divided by 4 factorial. There is this much of permutations related to these. I showed you what I mean by that. It's not easy to talk about everything, really. Sometimes you have to have a situation to talk about things. But relative to each of these permutations, I could say there is this many permutations. So that means that I have to multiply this permutation by this permutation, and that would give me basically 5 factorial over 4 factorial. And so what that gives me is basically well, I could say, for example, I could say, I wish there was some algebra related to, if there was algebra related to the factorial notation, things would be much easier. You wouldn't have to simplify things all the time. But I have never come across any algebra related to the factorial notation. Anyway, over here I can write this as, for example, this 8 factorial, I can write it as 3 factorial, like times 4 times 5 times 6 times 7 times 8. And I can divide that by 3 factorial times 2. And then this 5 factorial, I can write it as 4 factorial times 5. And over here I have a 4 factorial. So I can simplify these two, I can simplify these two, I can simplify these two, and I will get basically, that's a 20, that's a 20, that's 42, that's 20. That's 42 and that's a 20, right? This is 20, this is 42, and this is 20. So that's the same thing as 400 times 42. And 400 times 42 is equal to 0, 0 over here, 8, 16, 0, 0. So that's the same thing as 16,800. So in 16,800 of those permutations, these letters always stick together or occur together. Number 2, 16,800. So you need to be, of course, you need to learn the logic of, it doesn't click the first time. It never clicks the first time. And even now, when I have to do, I'm doing this chapter for the second time already. Even now, when I have to do a particular case, I have to think hard about how to do that. But, well, once you go through that chapter once, then you will learn the logic of how to do things, how to basically count things using this new tool that you have, which is basically permutation. And then after that, we'll have also another tool which is called combination. And then using these two tools, when you put them together, you can count all the way up to infinity. It's very easy to count all the way up to infinity when you have the factorial notation, and when you have the basically permutation and combination. And when you have a couple more things, like for example series and infinite series and things like that, then you can go all the way up to infinity. And infinity is not would not be a meaningless concept to you. To me personally, infinity was always some meaningless concept. I didn't know, something that you don't, you think of infinity as something that, the further that you go, the further it gets away from you. And so that means that logically you never get there. But then again, using logic itself, you can actually get there. You can actually count all the way up to, well, infinity really. So, now that I think about it, it's like you go through a process you don't even understand, consciously probably you don't even understand that you're going through this process. But when you go through this process of, well, which is learning mathematics, then the concept of infinity will start making sense to you. Now that I think about it, I understand the concept of infinity, although I really don't know how I got there. It's through all of these different concepts that I happen to learn in different chapters of these books, and then when you put them together, it makes sense really. Okay, now the next part that we have here is another part called the third part of this question that we'll do in this video as well. Okay, so the next part of this question is part 3 of this question. Do the vowels never occur together? So then You want to know in how many of those permutations, do the vowels never occur together? Do the vowels never occur together? Okay, so to answer this question, you need to calculate. So you want to know in how many of those basically permutations that we calculated, being basically the total number of permutations, which was 1,663,200, which was basically 1,663,200 permutations. That was the total number of permutations of the words. After we took out all of the repetitions and everything, we came up with this permutation, right? So now we want to know in how many of those permutations do the vowels never occur together. So you need to know in how many of those permutations do the vowels do occur together, and then subtract that from this permutation to get basically this one, right? So we basically the second part of the question was basically in how many of those permutations do all the vowels always occur together, and the number we came up with was 16,800. The number was 16,800. I think this was a number, right? So then to answer this question, you can simply just subtract this number from this number. So you would get basically 1,663,200 minus 16,800 would be equal to 1,663,200, and over here you have 16,800, and then you get 0, 0. For example, here you have let's say a 5, 13, 12, and 12. That's a 4, that's a 6, that's a 4, 6, 1, so that's 1, 6, 4, 6, 4. That's 1, 6, 4, 6, 4, 0, 0. 1,646,400, I suppose. And part 5 of the question is in how many of those permutations do the words begin with I? Do the words begin with I and end in P? And end in P. Okay. Now, so basically we have again the word independence. So you have basically 12 letters. These letters repeat themselves and so on and so forth. So if I'm assuming that I'm making 12 letter words using these 12 letters, so I want the word to begin with I. I want the word to begin with I and end in P. And end in P. right? Now we need to check here with see what happens here. So I does not repeat itself, right? And P does not repeat itself either. So that's just, you could just treat those two letters as two simple letters which do not repeat themselves, just two simple distinct objects. So since these are two distinct objects, then I have basically 12 letters in total. 12 letters in total. So what I need to do is that, so since the word is supposed to start with an I and end with a P, so I can fix this I over here, I can fix this P over here. So there's only one way of filling this placeholder, just because there is only one way of using the I over here, which is, well, just using the I. There is only one way of using the P over here, which is again the same thing, using the P. And then there is, and as you can see, I have already used 2 of my letters here. So I have 10 letters left. 12 minus 2 is equal to 10. So there are 10 ways of filling this. There is 9 ways of filling this. 8, 7, 6, 5, 4, 3, 2, and 1. So and there is basically one way of doing this here. So that there you have a 1 over here, you have a 1 over here, that doesn't really matter. And this number, and by the fundamental theorem of, not theorem, there is no theorem there, by the fundamental principle of counting, then you can say that the total number of the permutations related to the word is, so the total number of permutations of the word is basically, well, this is 10 times 9 times 8 times 7 times 6 and so on, all the way up to 1, which is 10 factorial. You have 10 factorial here. Now you have 10 factorial, and but as you know, these letters do repeat themselves, so I have to account for them. So you have N repeats itself, basically appears 3 times, D 2 times, E 4 times. So 3, 2, and 4 I have to take out. So 3 factorial times 2 factorial times 4 factorial, that is equal to, well, I can write this as 4 factorial times 5 times 6 times 7 times 8 times 9 times 10, and divide that by, well, 3 factorial is 6, that is 2, and that is 4 factorial. And then I can simplify these, and then 6 and 6 you can cancel out, 2 and 8 you can simplify. And so over here you have 35 and 36, and then you have a 0 over here because you have a 10 over here. So that's 35 times 36. So 6 times 5 is equal to 33. 6 times 3 is equal to 18. 21, 0, 15, 1, 9, 10. So you have 0, 6, 2, 1, and then you have 0 there, so that's 12,600. That's 12,600, which is the right answer here. Now there is a couple of exercises here as well, 11 of them. We will go through a couple of those exercises as well to just, if there is, to see if there is something important or interesting or something like that there in the next video, of course. And then we will start basically talking about combination. So I'll see you in the next video.